Evergreen. We're going to do Chapter 6, Lesson 9, Vertical Motion Problems. So we have done distance, where we find out how far or fast something's going straight across. You can imagine it going straight on the ground or on a street. Now we're going to be talking about going up and then down, vertical motion. So here's kind of a picture of this. You could imagine something going woo, back down to the ground, right? Okay, so we are learning a new formula for vertical distance. And vertical means something that's going up, and then gravity's making it go down. So you imagine you throw your apple up in the air, and then as soon as it reaches its highest spot and it runs out of speed, it starts slowly going down with gravity. And so this is the formula. Rate times time minus 5t squared. D stands for distance that it's traveling. The vertical distance. R is the rate in which it travels, like it's 20 meters per second or 5 meters per second or 5 miles per hour. Okay, and then we figure out our time, how long it takes to get a certain distance. So let's look at A in our book. This is our first example, and it says, give an equation for distance above the starting point in terms of time if each object has the given initial upward velocity. So basically it's saying upward velocity. That means something is giving it a big force to go up. And then it's going to calm down because of gravity. So if you throw an apple at a speed of 6 meters per second, let's use our formula, distance. We have 6 meters per second, so 6 goes in that R section for the rate, times t minus 5t squared. Let's practice doing this. If someone shoots a bullet up into the air, and let's say a ceremony, a soldier does this. Well, the bullet would be going 700 meters per second, so it's 700t minus 5t squared is the distance. Okay, what if someone's throwing a cable or a rope up into the air? It would go up 3 meters per second, and so this is our formula. 3t minus 5t squared. So that 5t squared stays the same and the t minus stays the same. We only are changing the constant in front of t. Okay, so if someone's throwing a football 25 meters per second, how far will it go after 2 seconds? Let's calculate this. So we have our formula with 25 meters per second, and now we know seconds is t. So that's times 2 seconds. If we calculate this out on our calculator, it would travel 30 meters. And so we would get 30 in our calculator, and the reason I would know that it's meters is because I went up here and it said 25 meters per second. So we know seconds. So in 2 seconds, it would travel 25 meters. Now, it's not exactly 2 times 25, even though it's 25 meters per second, because we're not going straight, we're not going horizontally, we're going vertically, so speed is not moving at the same rate. Okay, so what about if we were going for 3 seconds? We would insert our same formula, 25 for our rate of speed, 3 for our seconds, minus 5 times 3 squared, and we would travel 30 meters also. So we actually, between 2 seconds and 3 seconds, we don't really travel that far of a distance and change. Okay, and now this time, instead of telling us how many seconds we've been going, it tells me how far we have gotten. So it says, if you've gotten 20 meters, how long did that take you? Well, this time we know the rate and we know the distance. And so we end up getting 25t minus 5t squared. And we are going to actually turn this into standard form, like a quadratic formula equation in standard form. So we're going to move 20 over, so we'll subtract it. And then we rearranged our terms so that negative 5t squared was first. That's our A. 25t was second, that's our B. And then negative 20, when we moved it on the opposite side of the equal sign, negative 20 is our C. And so, remember, we're still having to solve this for t, how long it's taking us. And so we are going to solve this with our quadratic formula. So we're going to plug in x is equal to negative b plus or minus the square root b squared minus 4ac all over 2a. So we plug all of our numbers in. We hit enter. And we do this twice because we have to do it first with adding and then second with subtracting. And we get 1 and 4. Now, what this means, we have two numbers. You remember our kind of arc that we saw? It goes up then down. That means that it hits 20 meters at 1 and 4 seconds. So you can imagine something getting thrown. After 1 second, it hits 20 meters, and then it goes all the way up, and then it goes all the way down, and after 4 seconds, remember that was what we said? It says 1 and 4 seconds. So this is 1 second, and this is 4 seconds. It hits it again at that 20-meter mark. Okay. So when will it hit the ground? Well, the ground, how far would that be? What would the distance be for the ground? If it goes all the way up and then all the way down, back to the ground would be 0, right? And so we were going to solve this all over again, except with 0 as our distance. And so we're going to do the same thing. We're going to multiply. We're going to move that 0 over and rearrange our terms. We're going to plug these into our quadratic formula. And we're going to enter this into our calculator. First, we're going to add, and then we'll subtract. So we'll have two answers. And so this football will hit the ground, or basically start at 0 at the ground. And it also, 5 seconds later, because remember we're solving for t, that's time. 5 seconds later, it will also hit the ground. So in a total of 5 seconds, it will go all the way up and all the way down. 0 seconds, throw the football, 5 seconds landed. Okay, and so then there's more problems. Number 2, we're going to go over this baton question. So this is the same type of thing, except for instead of throwing a football, we're going to throw a baton. And that is it. The baton's going to go at a little different speed, 20 meters per second. So we're going to write down our formula. 20 is our rate, meters per second. And it says, how far will it have gone after 2 seconds? So we're going to put 2 in for our t. We're going to solve this, and it gets 20 meters. It goes 20 meters in distance total in 2 seconds. Okay, and now this time, instead of telling me time, it tells me meters. So meters is my distance. So I have d, which is 15 equals 20 times t times negative 5t squared. We're going to multiply, move that 15 over, so it'll be minus 15. Rearrange our terms, so we have a, then b, then c. Enter it into our quadratic formula. And we will have 1 and 3. So at 15 meters, it will hit at 1 second, it'll hit 15 meters. And at 3 seconds, it'll hit 15 meters. So that means basically, if this is 1 second, that means that really we're starting down here, throwing the baton, and then whoop, 1 second, 2, 3 seconds. So this kind of shows someone throwing their baton, and it's hitting this 2 times. It's hitting this at 1 second and 3 seconds. 1 and 3. Okay, when will it land back in her hand? And her hand is like where it started, correct? Yes, so it started in her hand, she throws it up, and then it lands in her hand, she catches it. And so her hand is like 0 distance. Basically, when does it get back down to her starting spot? So we're going to do the same thing, equaling 0. And we're going to do this exactly the same way. put this into our quadratic formula, hit enter, and it will start at 0, right? 0 seconds. It will start, and then it goes all the way up in the air, and then she catches it all in 4 seconds. Okay, now here's a baseball question. It's exactly the same, except instead of throwing a baton or throwing a football, we are hitting a baseball. So the baseball's going to go smack up and then down. And so the baseball is traveling 30 meters per second. And it says, how far will it go after 2 seconds? So we have our formula. Distance equals rate times time minus 5 times time squared. So we know 30 is our rate. Let's plug in 2 for our time. We're going to solve this in our calculator and we get 40 meters. So after 2 seconds, it will have traveled 40 meters. Now it says, what if we tell you meters? Can you tell us how long it would take? Yes, we can. We just have d equals 30t minus 5t squared, and instead of d, we're going to write 25. Then we're going to multiply 30t and negative 5t squared. We're going to move negative 25 over. We're going to rearrange our terms. We're going to plug them into our quadratic formula. We're first going to solve it with adding and then solve it with subtracting. And then we will have 1 and 5 seconds. It will travel 25 meters in 1 and 5 seconds. Okay, and so when she initially hits it at the baseball, it will hit 25 meters at 1 second, and then it goes up more, and then it starts coming down, and it hits about 25 meters again at 5 seconds, and then it keeps going down all the way down to 0. Okay, so when will it hit the ground? So ground is 0 distance. We plug that into our D. We solve. We move 0 over, we rearrange our terms, we put these numbers in our quadratic formula, we solve 0 and 6 seconds. So it starts at 0 ground at 0 seconds, and it goes up into the air and it goes back down all in 6 seconds. It hits the ground. Okay, I hope you understood that, but if you don't, you're going to learn so much about this in physics. This is just kind of like a little introduction to the vertical motion. I hope you have a great day. Bye.